Good afternoon. Happy Monday. Welcome back to the B&H Event Space. You're tuned into Audio 101. This is a four-part series where we're going to be diving into, guess what, audio. Today, part one, we are going to be demystifying audio terminology. Yes, we're going to start easy with the guys from Shure here. John Stack, Russ Helfman joining us. What's going on, guys?
Hey, how's it going, Derek? Thanks for having us.
Always. You guys are always welcomed on, although you make me a little nervous about my mic technique, my levels. I'm like, I gotta sound good if they're gonna be on. I don't want to do this whole series a disservice by starting off on the wrong foot.
You're doing great.
You
So
always
far,
sound
so good.
There we go. That's what I wanted to hear. I need a little coaching up today. So I'm going to throw it out to you guys now to get this thing started. But I do want to thank, of course, the entire Shore team for making this happen, the guys here and everybody behind the scenes, and also all of you out there joining us. Audio is important for more than just audio. So anybody that's into video, anybody who wants to get into podcasting, anything like that, that's why we're doing this series. We kind of want to bridge the gap between the audio pros and people out there like me, the weekend warriors. But if you guys do have any questions, feel free to drop them into the comment section on YouTube. If you don't know about our YouTube, well, now you know. Head over there where you can check out this and all of our other live recorded content. For that, I'll turn it over to the boys, and I'll see you guys in a bit for some Q&A.
Awesome. Thanks, Derek. So today we thought we would get started with some pretty basic, straightforward microphone technology. Let's talk about what a microphone is, first of all. So a microphone is a transducer. So it's basically taking your analog sound or your acoustic sound, and it's turning it into electrical information that passes down the wire and then goes out to your amplifier or your PA system, audio interface, anything like that. It's basically how you can get your sound from the microphone to its destination. And that's basically how it works, right? So if it's a transducer, and there's a bunch of different kinds, but they kind of fall into three main categories, and there are exceptions to this, but for the most part, they're going to fall into three major categories. So you have dynamic microphones, you have condenser microphones, you have ribbon microphones, right? So if we take a look at dynamic microphones, so these are the most commonly used microphones. You guys may all be familiar with this one right here. This is the SM58. This is a dynamic microphone. Also, Beta 58, very, very popular. These are the most commonly used microphones on stage. All right, they have excellent feedback rejection. They're sensitive enough to pick up your voice and pick up the detail, but they're not so sensitive like condensers that we'll talk about, where it's not going to pick up a huge amount of stage bleed, background noise, or a bunch of other undesirable sounds that you wouldn't normally want your microphone to pick up. So as far as dynamic microphones go, this is pretty much how they work, right? So you have three main parts. So you have a diaphragm, you have a voice coil, you have a magnet, right? So sound waves hit the diaphragm, which causes it to vibrate. The coil is a coil of wire that's attached from the back of the diaphragm that vibrates along with it, and that coil basically moves back and forth, passing in that magnetic field, kind of like. This is pretty much how a dynamic microphone works. You can see there. So that moving coil moves back and forth in that magnetic field, right? And that is what is taking your acoustic sound and converting it into electrical and sending it down the cable, right? So in the case of condenser microphones, you are typically going to find in a recording studio. You do see them live on stage as well, but they are very, very, very sensitive. They're designed to pick up all the nuances of your voice or your instrument. So it is going to be a lot more sensitive in comparison to a dynamic microphone. Because in a recording, if you think about it, when you're in the studio, you do want it to pick up all those nuances. And if you're speaking softly, or if you have like a piano or a string instrument that has a lot of detail, a lot of nuance to it, you really want that to come through in your recording. Whereas in a live scenario, yeah, of course you'd want that to come through, but it's not quite as important there. So as far as how they work, well, what's going to happen here is you have a electrically charged capacitor, basically. So when the diaphragm vibrates from the sound, the basically the space is what's going, or the vibration again is what is going to create that electrical signal. So you can see right there. So again, they are very, very sensitive. They technically, well, not, they typically, they're going to provide a smoother, more accurate sound in comparison to a dynamic microphone. All right. And that's condensers. And then you have ribbons. So ribbons, well, let's go back for a second. Let's talk about condensers. So with condenser microphones and dynamic microphones, you can have them in multiple pickup patterns, which we're going to talk about in a minute. So you can have omnidirectional, where they're going to pick up all around. You have cardioid, which picks up from right in front. You've got supercardioid, hypercardioid, which are tighter patterns. And again, we're going to look at those in a minute, and when you would want to use one over the other. So you can get all those different polar patterns with dynamic and condensers. With ribbons, they typically tend to be bidirectional by their nature. So they're going to pick up in the front, and then they're going to pick up in the back, but they're not going to pick up too much from the sides. So these are really, really popular for guitar amplifiers, brass, strings. They tend to have a really nice warm sound. They are very detailed, but not overly detailed. So they do sound really, really nice. They're not as commonly used as a regular condenser or a regular dynamic, but it just so you know, they are out there and they are great, great options. All right. So here you can see how that ribbon kind of moves sort of similarly to how the condensers work. You can see here, it's just a ribbon instead of a capacitor that's used. All right, so those are the three main types of microphones. So, you might be saying, okay, well, you forgot about shotgun microphones, you forgot about stereo microphones, but those tend to fall under one of those three categories, right? So, a shotgun microphone, for example, those tend to be condensers. So those will have supercardioid or hypercardioid patterns, but again, they do fall under that condenser category. So let's move on. Let's talk about phantom power, because this is something that a lot of people don't necessarily know what it is. They just know maybe they need it. It's a button on their mixer and they don't know what it does. So basically what phantom power is so condenser microphones need DC power in order to operate. It's what charges the actual capacitor inside the microphone. So it's typically 48 volts, and you would be hard pressed to find a mixer or an audio interface that does not have phantom power. So don't worry. Chances are, if you're watching this, if you're not sure if your interface or mixer or whatever has phantom power, chances are it does. It'll either say phantom or it'll say 48V or something like that. It could be on the top or the back of the mixer, but they're usually there. And with most modern microphones, you really don't have to worry too much about, let's say, in channel 1 and 2, I have a condenser microphone that needs phantom power. And then in channel 3, I have a dynamic microphone, which does not need phantom power. So what happens if I press my phantom power button on the mixer? Is it going to damage that dynamic microphone? The answer is no. That's kind of where the phantom part of phantom power comes from. It basically goes where it's needed. So you really don't have to worry. There are some older ribbon microphones that could potentially be damaged by phantom power, but most of the modern ones won't. And especially microphones, again, like you're going to see really commonly, like an SM58. If you have your phantom power on, you're not going to damage the microphone. You're still okay. All right. So let's move on to polar patterns. Are there any questions? Anybody in the chat or anything have questions so far?
No questions so
Yeah,
far.
nothing? Cool. So let's talk polar patterns. So polar patterns are basically referring to where the microphone is looking to pick up the sound from. So an example of that, excuse me, is here. So you've got omnidirectional microphones, which sort of like our SM63 microphone is omnidirectional. So this means that the microphone is going to pick up all around it. So an omnidirectional microphone is really, really good for interview situations where I might be talking into a microphone and then maybe I'm going to hold it up to the person that's speaking, or if I hand it off to somebody that maybe doesn't have the best microphone technique and maybe the microphone starts over here and then it ends up down here by the time they're done, or for a news conference where you have a ton of microphones that are up on a podium somewhere, but you might not be able to get the mic directly in front of the person's mouth. These are really, really good at picking up sound all around it. So you don't necessarily have to talk directly into it. The other nice thing about omnidirectional microphones is that they don't have any proximity effect. So proximity effect is something we're going to talk about in a minute, where if you really get up on the microphone, you're going to have a lot more bass and it's going to have that big boomy broadcasty sound. And then when you pull away a little bit, it starts to sound a little bit more natural. But then if you get too far away, the sound kind of thins out a lot. So that's what proximity effect is, and that is not really a thing for omnidirectional microphones. So that's a good thing if you find yourself in that situation. Um, the most commonly used microphone, especially for stage use, is going to be either cardioid or supercardioid. So here's the SM58, which is a cardioid microphone. And then this is the Beta 58, which is supercardioid. So main difference here, cardioid, if you think kind of like a cardiologist, deals with the heart. And if you look at cardioid, it's an upside down heart. So if you kind of think of the heart kind of coming out like this, so the microphone is going to pick up best right in front of it. It will pick up from the sides a little bit, but it will not pick up from the back. So why does it matter that sound isn't going to pick up from the back? Well, what if I'm a lead singer or instrumentalist on stage and I have floor monitors in front of me that are blasting straight up at me so I can hear it. So something like a supercardioid microphone, which has from the front, it has a narrower pickup area, but it does have that little kind of bud in the back that you can see on the chart there where it does pick up. So what'll happen is if you're on stage and you have a speaker coming directly up at you, you probably want to go with a cardioid, or you can very simply just take that floor monitor and just push it off to the side a little bit. And now you're in that kind of null point of the microphone where it won't be picked up. So then you don't have to worry about feedback or anything like that. So cardioid, supercardioid, hypercardioid is like supercardioid, just even tighter pickup pattern. So if you're in a really, really noisy environment and you really need that sound to focus in and not pick up too much extra sound from the sides or the back, supercardioid, hypercardioid, that's really where you want to be. And you'll find that most shotgun microphones are going to be supercardioid or hypercardioid because the whole point of the shotgun mic is to kind of point it at what you want it to pick up and then not pick up really anything else, right? Bidirectional, again, we said ribbon microphones can be are inherently they are bidirectional. Um, Large diaphragm condensers can be switched. If they have switchable polar patterns, they can be switched to bidirectional. So that could be used in many, many different situations. It could be, for a podcast, if I had two people, I could just put one microphone in between us, and then it'll pick one person up from the side, it'll pick me up from the front, and then it won't pick up anybody else from the sides. If we wanted to, if we're doing instrument, any type of recording of instruments, and we wanted to pick up a guitar amplifier or whatever instrument you're recording, plus a little bit of the room because it'll give it some more ambience and a little bit more space. That's what it could be used for as well. So the angles and all the specs here and degrees and everything, they'll give you an idea of the pickup pattern or the pickup angles, but every mic can be a little bit different. All right, and here you can see a little bit better as to what those polar patterns look like, right? So if you look at the top row, you can see that you've got really no pickup from the back on the cardioid. And then you do have that little bit of a lobe on the supercardioid in the middle. And then omnidirectional is just picking up all around it. So that gives you kind of the 3D model of everything there, right? And then on the bottom, it's basically showing you just from a different angle what's happening with the pickup pattern, all right? And now if we talk about frequency response, so frequency response refers to the sensitivity of the microphone at particular frequencies. So the lowest frequency that the microphone is capable of picking up, and the highest frequency that the microphone is capable of picking up, and then everything in between. So very often in your microphone manuals from whatever microphones you may have, you'll see something that looks like this. And you might not look at it and say, okay, well, I don't know what 2K sounds like, or I don't know what 300 hertz sounds like. But what you can do, if you kind of equate this to an equalizer that you may have seen on any number of stereo systems you may have owned, you can kind of think of it like that. This is a lot more precise, but when you're looking at this, you're always going to have your lower frequencies on the left, and then you're working your way up to your higher frequencies on the right. So if you look at that horizontal line, you can see that there is a bit of a dip in 8K on this particular microphone, but you don't need to know what that sounds like. You can say, okay, well, that looks relatively flat in the mid range. There's a little bit of a bump in the higher frequencies. So that microphone may give us a little bit more air. It might give us a little bit more of that kind of shimmering highs and smooth lows. So if you look over here, this is the chart for the SM58. So the two polar patterns that you're seeing on the left, that is basically showing you the angle of the pickup at what frequencies. So this could get a little bit complex, but what it's showing you basically is um, at three different frequencies how uniform that pickup pattern is. So at 125 hertz, which is pretty low, you'll see that it's almost kind of omnidirectional. And then as you get to the higher frequencies, the 500 and 1000 hertz, now you're seeing that kind of heart shape form a little bit more, because bass frequencies tend to be a little bit more omnidirectional, and they're a little bit harder to tame in dynamic microphones, which is what I don't have the KSM8 here to show you, but I have our new Nexodyne microphone, which takes something like these charts and makes it a much more uniform polar pattern pickup. So with a Nexodyne microphone, for example, if my low frequencies are going to be picked up just as much as my high frequencies, it's much more uniform as far as the pickup pattern. So that's a really, really nice thing about the Nexodyne microphones that just came out a couple weeks ago. They take that polar pattern and just make it completely uniform across the frequency spectrum, right? So this is the SM58 as an example. Here's the Beta 58. Now, the reason that I wanted to show you the Beta 58 here is on that chart. Again, if you're not familiar, this is Beta 58 right here. So the chart on the left is actually showing you proximity effect, what we were explaining before. So when you have your microphone right up on your mouth, you have a lot more of those bass frequencies. So what it's showing you here, that top dotted or dashed line, that at 3 millimeters, it's showing you how much higher those bass frequencies are going to be versus at 25 millimeters or 1 inch versus at 2 inches versus at 2 feet. I mean, you're not going to want to use this microphone at a 2-foot distance, but it just goes to show you what that difference in the proximity effect is, right? And here you go. This is the textbook definition of proximity effect. So it's like it says here, it's not necessarily a good thing or a bad thing to have proximity effect. If you are in a podcasting situation or broadcasting, and you want that big boomy broadcasty voice, a lot of that does actually come from proximity effect. But if you're, recording an album with your band and you have instruments, you might not want that proximity effect there. So some microphones, like you can see here on the bottom right, our SM81 instrument microphone has a low cut filter. So what you can do is you can basically tell that microphone, okay, well, we don't want it to pick up any low frequencies below, X number of hertz, and the microphone just automatically doesn't look for it. So a lot of microphones have that feature. So depending on whether you want that proximity effect or don't want it, you can actually control it from a lot of these microphones themselves. All right, so let's get into just some techniques, speaking of proximity effect and things like that. So if you're on stage, when you're doing your sound check, everybody always gets up and test one, test two, and all of that. But what you really want to do is do a practice song if you can, or sing at the level that you're going to be singing during your performance. Because if I'm just sitting here going, test one, two, and then I'm singing on stage a lot louder, that level is going to come across a lot hotter than it did in sound check, and now it's more work for the sound guys. So you always want to do, when you're doing sound check, sing the way that you're going to sing during your performance, so that way the sound guy or whoever's running your sound can get your levels. Another tip: leave a little bit of space. Again, unless you want the proximity effect, which could be desirable for certain people depending on your voice. So usually what you want to do is you want to go 2 fingers, and here's my mic. This is pretty much where I want to be, right? So an inch or two. All right. The other thing is you really want to make sure that you kind of draw an imaginary line at the front of the stage or in line with where your speakers are. You should always be behind your speakers, or your speaker should always be in front, I should say. Because if I'm standing right in front of a speaker, the sound from the speaker is going to come out, it's going to go into my microphone, it's going to come out of the speaker, it's going to go back into my microphone. It just creates that cycle, and that is how you get feedback. So you always want to create, if you're standing at the front of the stage and you've got speakers to your immediate left and immediate right, you're usually okay. Maybe just take a step back so they're in front of you, just to minimize the amount of sound that will get back into that mic, and that will help you to eliminate any feedback. Most importantly, don't cup the mic. It looks cool. It doesn't sound cool. We put handles on here for a reason. And what happens is when you cup the microphone, you are essentially hindering or changing the frequency response as well as the pickup pattern for the microphone. So what you're getting out of a microphone when you talk like this is not truly the sound of the microphone itself. So always want to use the handle to hold your microphone, whether it's a Shure mic or another brand's, and that's it. Just don't cup the mic. All right. And I think that's what I've got for you today as far as presentations. Are there any questions or anything?
Yeah, we'll open it up
Stop
now
sharing
for
my screen here.
questions. I'll make sure not to cut my mic. You ratted me out to the entire world, Russ, by talking about this proximity, because everyone's like, you have such a great voice. And I'm like, no, it's just online.
It's
That's why I won't
proximity
meet
effect.
people in person.
Well, yeah, I mean, you do have a wonderful voice.
Oh,
Proximity effect or not, you do have a
there
very
we go.
nice, smooth
As one
voice.
of our guests so
There you go.
eloquently stated, is it the mic or the man? I'm like, no, it's the mic. It's not the
It's the
man.
man. 100%
Yeah.
the man.
Well, let's get it started. I know you had a lot of talk about between the SM58 and the beta,
Yeah.
and we discussed the patterns of those. Is it just the pattern that makes those different, or what's the difference between the beta versus the SM58?
Yeah, so there are a couple different differences. So it's actually interesting. So SM58 came out in I believe it was 1966, and then the beta came out I think it was 1996. And you want to guess why they call it the beta?
What is it? Just a smaller,
Well,
lighter?
if the SM was considered the alpha, then
So it's
the
as really
idea It's the beta. Yeah, the idea was that the SM58 was doing really well, but there were some things that artists and engineers wanted tweaked with it. So basically, what they did was so they switched it from cardioid to supercardioid, so it's got a narrower pickup area, right? The frequency response is a little bit different, and it has a hotter output. Those are the three main differences between the beta and the SM. So
Okay.
depending on where you are, if you're on a stage and you're in a noisier environment, then the beta might be a little bit better way to go just because of the narrower pickup area, and it'll kind of reduce the stage bleed from, you know, a drum set most commonly if you're playing music, um, or anything else that might be going on stage. And actually, I'm going to bring back the Nexodyne microphone, which does an absolute. I'd love for it to focus in. Here you go.
Where-
So this is Nexodyne. So this came out a couple weeks ago. There's cardioid and supercardioid versions of this. And what they did with, I don't want to get too technical on this again, but what they did was when we were talking about having the different types of transducers in the microphones, there are actually two full transducers inside this microphone. So what it does is you have the signal coming in, and then you've got another transducer that's wired to it with the phase reversed, basically. So what happens there is it's creating a very, very linear and very uniform pickup pattern across the frequency spectrum. So with like the SM58 that we saw before, that had more of an omnidirectional pickup pattern in the lower frequencies, this is uniform from the low frequencies all the way up to the high frequencies. And then the off-axis rejection, which is probably something that I should have added into the slide deck, basically means where the sound is not coming from, right? So if I want to talk into the mic, I want to talk in here, but I want it to reject the sound coming from the sides, right, off its axis. So if I talk into the microphone like this or like this, I don't want it to pick up that sound. And these microphones do a phenomenal job reducing any stage bleed, especially from cymbals coming in behind you off the stage. Guitar amps all around you on stage. This microphone just does a really great job at isolating what you want and keeping out the things that you don't want.
Okay. When you were talking about the patterns, it's interesting because I always thought I don't have a mic here, so I'm going to use my remote control. But I always thought it just looked cooler, when they hold the mic up like this.
Oh, it
So
looks
is
cool.
that's all
It looks
are
cool.
mostly technique? Technique is you're really just
Yeah.
speaking to where the mic.
Yeah. Yeah. I mean, you basically, when you have a lot of people that hold the microphone like this
Yeah.
isn't I guess it's not terrible because, this is where the microphone is picking up from. So you want that to be clear,
Hmm.
right? So if I start going like this and cupping the microphone, that's going to affect it. Although I
Yeah. Or
will
if you're
say,
holding it like straight up,
if you're holding it straight up
like a
like this,
broadcaster.
you're okay. You're okay. Yeah,
Okay.
that's totally fine. You can talk across the microphone. You can talk into the microphone. You don't want to like talk into the side like this.
Don't
That's
talk into the
don't do
underside of
this,
the
kids.
microphone.
That's right. Kids at home, if you're watching, don't do this. But yeah, yeah, this microphone, I will say, if there is anyone that uh insists on cupping the microphone, this is the one for you.
And is
It's
that just because it's the most neutral? It's
it's
gonna
because it's neutral. It's because of the way that they have that second motor or second transducer wired up. Basically, what it's doing is it is essentially eliminating any type of handling noise and a lot of those really low frequencies that come through there. So while again, this is not how you should be holding a microphone, um, the fact that the polar pattern is so uniform and with everything that's going on inside of the microphone, it doesn't make as big of a difference as it does with an SM58 or a beta or anybody, anybody else's microphones.
okay.
It's not proof.
Another question regarding windscreens. When is it necessary to go on? And you have some mics where you
Yeah.
have you see them used with and without the foam, and it's like, is what really, how much of a difference does
Yeah.
that make?
So, I mean, technically speaking, the foam windscreen you can use, like if you're outdoors, you should definitely use one.
Hmm.
No question there. If you're indoors at a, a concert venue or something like that, you can pretty much take it or leave it. If you have, if you're sharing a microphone with someone that drools or spits all over it, I would definitely recommend using the windscreen. But as far as what it's actually doing, if you're indoors, it's going to protect against plosives, um, and your P's and your T's. It will help you out with that. However, I'm not sure how well this is going to come through on screen, but this is the girl for the SM58, for example.
Okay.
If we look inside, it does have a thin piece of foam in there, so it
Oh,
already
no way.
has a foam windscreen built in. Most of our microphones do. In fact, I can't think of a dynamic mic handheld that doesn't have one. So yeah, so you've got it in here. So by putting on another foam windscreen, it's just a little bit of extra help for your plosives if you need it. Now, if you're outdoors, figure, if you're a newscaster or you're doing location sound, these foam windscreens are most likely going to be necessary. So figure if there's a breeze up to like 9, 10 miles an hour or so, you're pretty good with a foam windscreen. But once the wind gets higher than that, that's where you want to start using the furry windscreens. Those are going to go on top of the foam windscreens, and those actually they're going to do a better job than just the foam itself because it's creating more of a barrier for the wind to actually get through into the capsule of the mic.
Or if you have really bad plosives, like you said, like me, there's
Or if you have
sometimes
really
when I
bad plosive.
listen, you
Yes.
know, and I think this is good, since we're breaking it down audio 101, that's something that even a lot of people probably don't pay attention to, the S's. And,
Yeah.
I started going down a rabbit hole of like how to DS, when I can't say it, how to DS when I speak, when I go in post production, and how to take that out and the plosives and all of that. And I guess it's the same
Yeah.
mentality as when you're doing photo. You want to get as much right at the time of. You want to use the right mic, you want to use the right technique for the settings and for your voice, and then minimize the amount of post production that you have to do on.
Yeah, yeah. I mean, especially now, with technology and all the plugins that you can get for de-essing and all the AI stuff that's out now. I mean, it's certainly, I think, a matter of just how you prefer to work at this point.
Mhm.
I'm a believer that you should get it right at the source. That way, you don't have to do much editing in post or minimal editing in post, we'll say. But there are certain people that just capture the recording and are more comfortable doing it in post, and there's nothing wrong with that at all. If it sounds good, then it's right. That's really it.
Yeah. Look, I'm a fan of that. That's the lazy approach to everything. Do it right. You don't have to
Just
do it again. You don't have to do any extra work.
yeah,
So,
yeah. I mean, again, if you can get it right at the source and then not have to do that much work in post, that's always going to be your better option. But again, it's comes down to your workflow and how you're most comfortable.
And Derek, one more thing, speaking of windscreens too, that typically you'd wanna, if you're in an outdoor environment that has a little wind and noise going on, you'd want to stick with a dynamic microphone because a
Yeah,
condenser, just by nature, is more sensitive. So obviously it's going to pick up wind a lot more. So
absolutely.
even though in a studio or some singing environments that the condenser might be the best choice, if you have any type of wind, you want to avoid that microphone.
Right.
so
So
something like this, because I've noticed it's like sometimes I put my mic up, I leave my mixer on, I leave my mic on, and I'll have my headphones on, and I hear like, I'm like, wow, this is actually picking up. Because when I speak on here, and it's like everything, I'm right up on the mic. I guess it's blocking out. It's picking up my voice predominantly, but when I put it away, I'm like, wow, it's incredible how sensitive it is. For it shields it out when I'm talking. But then
right.
if I were just to put it up, and it's like I'll hear like a door shut all the way across my apartment, I'm like, wow, I'm surprised I can't even hear that.
Yeah.
And
I mean,
that's
a
just
lot
due
of
to the
that.
pattern, right?
Yeah, a lot of that has to do with the pickup pattern of the microphone and the gain settings. The higher your gain setting, whether it's on an interface or a mixer or big console, whatever it is. It's kind of like the your gain is like the doorway for how much sound you're letting into the mixer, and then you can control that with the fader. So gain is not volume per se. So
I'm
yeah, if you have that
glad you
gain,
went there because I was going to
yeah,
ask. I was like, I know a lot of people probably mistake the two or they conflate gain and volume. And
yeah, it's I mean, technically, yeah, you turn the gain knob up on your mixer, it gets louder. So yes, there is some truth to that. But ultimately what's happening is the gain on your mixer or interface is kind of like we're opening up the door a certain amount to let that much sound in. And then I can take my fader, and if I railed my fader and it's as high as it can go, it's only as loud as my gain setting. So if I set my gain properly on my mixer to where I can, sing at my regular volume or even get a little bit louder than that, without clipping, I know that I can push that fader all the way up on the mixer, which I'm probably never going to do, but I can push that mixer all the way up and I still won't be clipping. So
okay.
that's also, just setting your levels properly.
Now, without spoiling anything from future episodes, is it kind of the same mentality of like for my photo people, when we bump the ISO, it's in a low noise or a low light environment, but there's a compromise.
Yep.
You're able to get more light in to hit the sensor, but there's more noise. Is it kind of the same idea? There's a trade off where you're getting more volume, but you're also bringing in, it's not necessarily
Yeah.
clean if you push it too much.
Yeah, it's very similar to that. Yeah, I mean,
Okay.
I'm not a photographer, but I do know about ISO, and that definitely makes sense. Because yeah, if you're gonna let more light in, then you're probably gonna have a higher exposure, aka noise, that you don't really want.
Yeah.
So yeah, it is very similar.
Okay. Makes sense. Look, this was broken down very well. The diagrams are great. I'm gonna have to go back and obviously rewatch and take more notes because I think, can always it's like not native to most of us. And I think that's why it's great, and I want to thank you guys again for doing this series because audio is something that it's actually fun the more you learn about it. And we don't realize how much you appreciate good audio because they never get credit usually. It's like, oh, this just sounds great. We treat it as normal sound until you
Yeah.
try to go out and record something on your own and you're like, this is horrible. This sounds, I
Yeah.
can't even listen to this.
Yeah. I mean, it's not rocket science, but there are some things that are helpful to know, especially when you're starting out. So that's kind of why we're doing this. So with this is kind of today is kind of like, all right, let's talk about the terminology that we'll need going forward, and then next time we're going to get into specific microphones for podcasting and how to set up for that. And then another episode we'll talk about, wireless microphones on stage and best practices and wired mics for recording. So each one will just be a different subject to tackle. So this was kind of just the intro to get everybody familiar with the terminology that we'll be using in the next ones.
Awesome. We got our swimmies on, we got our kickboards heading
Got it.
towards the deep end in part two. And we brought you guys along for the ride. So a huge thank you to John, Russ, and the entire Shore team for bringing us this series. And to all of our viewers out there, thank you for tuning in. Keep an eye on our website for parts 2, 3, and 4 that we'll be following. And that is it. That's all we have for now. Another edition of the B&H Event Space, and now in the books. Catch y'all next time.